Hi there, let's get started on the circle of Willis and CSF flow. Okay, so the circle of Willis, what is it? Why do we care about it? So the circle of Willis is going to be the blood supply that's going to the brain, and it's sitting here at the base of the brain. You can see this nice little overview. This is almost as if you're looking at the brain. If you were underneath the brain, you were looking straight up. This is pretty much what you would see. So you can kind of see all the red here. That's going to be circle of Willis. And so it really is extending from like the midbrain all the way down to like the pons and the medulla down here. So what is it? It's a ring of interconnecting arteries. And so it's actually forming anastomoses, which is where like two vessels are kind of coming together and sharing supply. So it's an anastomosis of the anterior and posterior supply. And I'll point out specifically which each of those are in the next view here. But specifically, it's coming from the internal carotid arteries and the vertebral arteries. So vertebral are coming up down here, and then the internal carotids are coming up right in here, so much more anteriorly. And why is this important? It's important because with the brain, it's very important for the brain to be getting enough blood to prevent hypoxia. The brain is one of the most sensitive organs to hypoxia. So you want to make sure that you have all of these different kind of like highways for blood to come in and be supplying the brain. Okay, so this is a little diagram that I found on the internet, and then I kind of made our own based on what you need to know in your checklist for the anatomy course with Professor Craig. So just kind of starting out here, so I just cut off the extra stuff. But here we have the vertebral artery, so this is going to be part of that posterior supply that's going to be coming in. So vertebral arteries, which are coming up on either side, right? Next, we have the basilar artery, and then this is the middle cerebral, and then up here, oh, I'm sorry, the posterior cerebral artery. Then we have the middle cerebral artery, and then finally we have the anterior cerebral artery. So I actually like to think of it as if you can find the anterior cerebral artery, the middle, and the posterior, then you can figure out the entire rest of this diagram. Because then the only things that are left to know are the posterior communicating artery, the anterior communicating arteries. And so those are literally just like the little passageways in between here. So posterior communicating, and then there's also an anterior communicating right here, just a tiny little one. And then finally, the carotid artery or the internal carotid artery is going to be right here. So that's going to be coming up. And remember, the carotid, the common carotid is going to be traveling through the neck. And then at a point it bifurcates. So then you have the external going off and living its life more superficially. But then the internal carotid is coming in to feed into this circle of Willis to maintain the blood oxygen levels for the brain. And remember, there are other things that come off. There are a ton of little pontine arteries that come off here and a ton of little cerebellar arteries, but you don't need to know those. So if you'd like to learn them, definitely go and look them up. It would not hurt you in your studies. All right, and then moving on to the cerebrospinal fluid. So I'm going to call it CSF for the rest of the time here. But what is it? Again, why is it important? So it's a clear fluid that is surrounding the brain and the spinal cord. So it's going to be surrounding the central nervous system. It's produced by the choroid plexus in the ventricles of the brain. So we'll get to a point here where we see on the next slide, I believe, maybe the one after that, a display of the actual ventricles and how they flow through the brain. But just know that the choroid plexus is the structure that's actually producing the CSF, and it's lining parts of the ventricles. It functions to deliver nutrients, remove waste, and to cushion the brain and spinal cord. So that's really important. It's its own little highway system, if you will. And then it's going to be absorbed by the arachnoid villi. So it's kind of just going to be sucked back in, and it goes into like the venous drainage and everything when it's been used up. Okay, and then the CSF flow is going to be important for you to know. So We'll start out here, and we have the lateral ventricle. So there are two lateral ventricles, and the CSF is going to be, again, remember, produced in the ventricles, so the lateral ventricles, third ventricle, and fourth ventricle. So CSF is starting its journey at the earliest point at the lateral ventricle. It's going to be traveling, it goes through the interventricular foramen, or the interventricular foramen of Monroe, whatever helps you remember it. And then it's going to arrive at the third ventricle. And when it arrives at the third ventricle, it will continue down through the cerebral aqueduct, and then it arrives in the fourth ventricle. And then it passes through the foramen of Luschka and Magendie, and then at that point, it's in the subarachnoid space, where it can then kind of cushion the brain and the spinal cord alike. Each of these, the foramen of Luschka and Magendie, those are kind of going through different places to either the brain or the spinal cord. They're different locations. I believe one is located more laterally. However, that's not important for you to know at this point. So here's this little diagram I was kind of talking about here. So looking at our CSF flow, there are really cool 3D images if you have a second to look it up and get a better appreciation of it. But remember, so we have this lateral ventricle. It's almost this entire space here. There are just other structures superimposed on it. And so the choroid plexus is going to be in part of the lateral ventricle. So it's going to be produced in here and then travel down through the interventricular foramen, at which point it is then in the third ventricle. Okay, so in the third ventricle, traveling down through the cerebral aqueduct into the fourth ventricle. And then once it's in the fourth ventricle, then it travels through a couple of little foramen, that foramen of Luschka and Magendie, and then it arrives at the subarachnoid space, okay? And that's all for this video. So please email me for virtual office hours to review any material. I'm more than happy to go over whatever you'd like. And I'm pretty flexible on timing, so just